So we have already two topics on the agenda, so we can get started. So we have the ROS2 access control policies, the ROS2 notes unboxing. Oh, and on a side note, so I will take notes in this Google Doc and post a link on Discourse after. It's the same docs than for the previous meeting, so I'm still continuing to take notes at the top of that. So maybe we can start with you, Rafin. Do you want to present the ROS2 access control policies idea you were thinking about?
Yeah. So if you go to the discourse thread, we've posted a link to the PR for on ROS2 design in GitHub.
Oh, okay.
There you go. So yeah, this is the PR for the access control policy definition. It includes both the sort of markdown of a summary of the policy format itself and design decisions and various other properties we'll want to take into consideration, as well as the schema itself that can be a living document to define the structure. So it basically contains sort of introductory on some basic concepts like mandatory access control, principle of least privilege, privilege separation, separation of concerns, and then some justifications on why we've used XML so that we can do we can easily do validations using schemas and transformations using templates, and we can do composition because XML is natively namespaced, so you can include other documents and the other things, and that makes it easy for reuse. The schema itself basically defines a global policy root tag that contains for future expansion, because right now we're just using a sub tag for profiles to enumerate all the various profiles. And the profile tag itself is defined by specific to a node based on its namespace and node name attributes. And that encapsulates whatever access that you would want to provision to that node. And the node is given various amounts of privileges, so you'll have different rules based on what IPC you're using, actions, services, topics. We'd like to expand that to parameters, but right now the documents are reflecting what exists right now. So we'll probably send a future PR to extend that to parameters. There's no big question on maybe how we do that too, but actions have different types of roles or like permissions, like because it's like this duality, like almost every IPC. We could probably generalize that to maybe a given rule type might have more than 2 permissions, but at the moment, actions have call, execute, services have reply, requests, and topics are publish and subscribe. There, of course, is the FN match support. Right now, the template transforms are just forwarding that to whatever transport layer. So we're not necessarily considering or interpreting the POSIX match. There's also like the danger of that. Currently, if you're using FN match to glob across namespaces for one IPC, It can cross-pollinate to another IPC. So let's say you give permission to all topics under a certain namespace. Well, then you've just given access to subscribe to feedback, topics and actions, which is, I think, violates the principle of separation. But right now, there's nothing. There's something we can do, but it involves digging deeper into how the RNW layer is implementing or using DDS topics. So I think I've spoken to those before, like where we could probably resolve that either namespacing the DDS topics with the associated IPC, but that makes the implementation a little bit more difficult in that you can't just reuse primitive IPC types to compose more higher level services or actions. Anyhow, so there's topics, services, actions. You specify what attributes, whether you want to allow or deny a certain rule. This is following a mandatory access control profile where it's denied by default, so you have to explicitly allow anything, and you can override that allow by explicitly denying it as well. So that allows you, like, maybe have like a var norm, guard a certain exception. So like for a node, you can give like a general permission, like star foo, and then you can revoke like foo bar star. So that's basically the schema. Then there's the templating, which basically does all the heavy lifting to transform the policy that is in sort of ROS-centric form to DDS. And that might change, and so then we can just update the template on how that's going to be handled. And it's nice that we're using templates because then we can generalize across, like outside the SROS2 CLI. If some other company is like, generating IT infrastructure to do this en masse, then they don't need the Python interpreter in our custom to interpret, this profile schema. They can just use Daxodalis templates and schemas to validate everything.
Hey, Ruffin, quick question. Sorry for interrupting. Back to you gave an example of providing a wide policy and then ratcheting it back. Is that evaluated? I mean, XML isn't really ordered, right? Is it evaluated in order, or is it?
So yeah. If you look at the templating, one of the important points is let me find it now. So the DDS permissions in the permissions file in like a particular grant, the allow and deny statements, I mean, they could be interleaved, and so they're just only evaluated in the order they appear in that document. And so to afford this level of explicitly allow and then override deny, this like sort of two-layer, then the template, what it does, it reorders all your deny statements to appear in the policy document before your allow. And then it attaches deny by default at the very end.
Okay, gotcha. That makes more sense. Thank you.
Mm-hmm. So that's the job done by the templating. And you can read all the various sort of steps here from 1 through 6 under the template section. And we talk about some alternatives. Like we initially started with YAML, and that was sort of like a holdover from what we did in SROS1. So like, YAML had its pros in that it was relatively human readable, had minimal line noise, had a pretty neat data model. It's like you could write dates and stuff in it, but that typing wasn't very well defined. It's easy to like mix up types. There was no very validation schema, so then you'd have to write all these safe checks in whatever processor, rather than just like asserting that the data is well formed before giving it to the processor.
Well, you didn't like the bang bang type format? Agree. Yeah. Quickly becomes unreadable.
Yeah. Composability, you can use anchors and things in YAML, but you can't like reference external resources unless we like started having a secondary interpreter language. With XML, we can do that like natively by just like calling XInclude in the document before we're processing it or even validating it. But we're thinking of maybe adding an additional sort of like ROS macro in the policy, so we can refer to packages in your that you have sourced, just like how the original ROS1 launch had like include packet or find package, and then you could specify resources of packages. We would probably use the ament index to maybe add profile like policy documents so that other packages could easily find it. I'm wondering if the ament index is worth it. I think because the XInclude is pretty powerful. Like, people might want to write their own custom XPaths and like what exactly they want to compose and import. Still thinking about that, but I think the ament might be a good choice. Expressive syntax, yeah. We could do like maybe custom. So AppArmor has its own custom profile language, and that allows you to be like very succinct, and you can add whatever syntax or grammatical features that you want. But I mean, that's a lot to maintain for a configuration language, and it would be sort of just on us. So rather, I don't know if that's worth it. Then there's ComArmor. It's sort of an inspiration of what the current generation of the schema we have now. I was thinking we could have like more like AppArmor. What it does is it takes like all your profiles and flattens that for you, and then gives that to the policy interpret engine and whatnot. Whereas I think with the current SROS, it might be better if we just keep it simple in that since like ROS nodes have to be unique in name, we just assume that the profile element is unique in its namespace and name attribute. No duplicates and no crazy attempts to try and merge, and no necessarily nesting of profiles and profiles. That's one thing you can do in AppArmor is you can nest consecutive profiles so that you can import them. But then it gets kind of hard and like how to interpret rules. And because of the way that we're mapping, these ROS rules for IPCs to DDS topics, it's more straightforward if there's like this one-to-one mapping. And it also helps demangling. So that's one thing that me and Mikhail did 2 weeks ago, was to do the demangling of DDS topics. So like if you take the DDS discovery traffic and then you want to infer a ROS2 policy from that, that's a lot easier if you're just considering sort of this flat profile space. We have some concerns. So again, separation of privileges, that gets into how, you know, people might misuse FN match, but that's sort of external. Just some things to be aware of if you decide to use expressions in your rules. Separations of concerns. So we were thinking of maybe extending the policy document to also define the protection kinds. So again, with DDS, you have the permissions document and also the governance document. You know, the permissions document specifies, you know, what limitations to an individual participant, whereas the governance sort of defines the rules of the game. You know, where are the rules of engagement? You know, are all topics encrypted? Is discovery traffic encrypted? All that stuff. Is it just signed? And so one thing you might want to do is for certain like high bandwidth, low sensitivity topics like, I don't know, weather data, you know, that's public. So you just want to make sure that it doesn't get modified in flight. So let's just sign that rather than encrypt it. So it would be nice if you could, or convenient for users, if, as well as defining permissions for nodes, they also specify what protection kind in the same spot this topic should be subject to. And that would help because then when this gets mangled into DDS, everything is sort of retained, and then it would generate a matching governance file that would respect what your intentions were when you generated the original policy. So it basically have an added pipeline. Mikhail has a PR, open PR for this, but to generate the auto-generate both the policy and governance file for every node. When we so separation concerns, when we add that, we probably want to think carefully like how much we want to expose. You know, some of these protection kinds are like specific to DDS. Like there's the sign versus encrypt. That's pretty conventional. But then like DDS has like sign with origin authentication, where you basically prevent someone from spoofing you by having every subscriber having a different MAC key. So that's pretty specific to DDS. So if we bubble up those kind of features,
it makes it less abstract, doesn't it?
Yeah, but
and yet it's still useful, especially the origin one. That's like my favorite feature.
One thing I think I described somewhere is like perhaps we could still have sort of like a namespacing of things. So for downstream for upstream packages that you might like import, you know, their profiles, or this is again the question of maybe with IDL, maybe we just generate this to begin with, but
well, this applies to the node IDL proposal as well. Yeah.
So you could specify protection kind in the permission rule, like say the actions tag and service tag. In addition to like request equals allow, you might have protect, or you might have like protect kind equals sign, or protect kind equals. So you could specify it maybe at the tag level. Another thing is you could also probably add that attribute to the profile, as well as maybe the profiles. And so the thing is like maybe the stuff you're roping in doesn't define what protection kind is, so then it's more generic. And then for my use case, I just stick on the attribute at whatever level of the namespace I want it to apply to. Like
and it would just apply to everything that didn't have a specifier below that or something.
Yeah.
Would that override something that upstream specified?
I think it might. I think the easiest case is like if you specify it explicitly below, it doesn't get necessarily override. So it's always the local scope that takes priority. That's what I was thinking.
Yeah, I think that makes sense. It does make it possible for security to be decreased without the end user knowing, I guess.
That's where I think I'd like to add more formal tools, especially like doing the demangling. So like one thing is that if you start adding this like protection kind, it might be possible for like two things not to talk to each other anymore. Like they're in the same policy document, but user specified this to sign and this to encrypt for a given action that they were supposed to talk over. Now they're not. So you'd like something to warn you about that. But it's not going to be immediately obvious because they're going to be in different governance. These
The DDS isn't going to help us there. DDS doesn't give you any sort of warning if two topics or two different nodes or participants are trying to talk over a given topic that has.
I think you'll get runtime errors where like, you know, the DDS security layer will like warn you that someone's trying to do this topic but isn't playing by the same governance rules.
Are those nicely bubbled up?
No, I don't think they are. Whatever SP out, the middleware put out, and then I don't think those were captured by like ROS logging or anything.
I have an unrelated question. Did you think of like leveraging the fact that now ROS launch are, you know, like much more extendable? Because a lot of what you're describing in the policy, you know, so I think there are two things. Like one, being a pub subsystem, so one of the principles is that when you publish, you don't necessarily know who you're like communicating with, you know, until you actually compose your final application. So that's why composability is an issue. It's because, well, you know, if I don't know, if whoever wrote TF, you know, didn't know what you know, with which node TF is going to talk to, right? And especially if you get out of the model where you know, you're just a robotic company building everything from scratch, and you still are in this world that OSRF lives in, where you have standard nodes, which, you know, in this case is a much harder world because you just either like don't put those policies in this Debian package, and it's, you know, and then the question is like, where, you know, is it okay for those policies to live, for a TF policy to live outside TF? You know, and if yes, you know, how do you make sure that it works well and the tooling in there and so on, right? And on the opposite side, well, if you think about it, so there is a layer in ROS 2 or in ROS 1 where you actually take all of the nodes and you say, hey, this node is gonna talk to this node and not to this other node. And it's naturally the launch file, because here you actually make those connections when you do the remapping. And I was wondering if you ever thought of just what you have in your XML file, you know, could also be a Python annotation, you know, like it could be implemented in whatever way you want in your ROS launch. And so you just say, hey, I have this graph, and then everything which is in the ROS launch, I'm gonna, you know, explicitly define it's a load. And then on top of that, I'm gonna open a few other you know, like communication channels which just don't happen at start for like ROS 2, CLI use case, debug, and like dynamic capabilities and so on. What do you think?
So if I got that right, you're saying performing the inference from the ROS launch in respect to the connectivity of the system.
Yeah.
And then what, generate the policies from that, or I wasn't quite sure where you're going after that.
Yeah, how does that relate to the security type, Thomas? Are you talking about actually specifying those types of things in the launch file themselves?
Yeah, like basically saying that, you know, so it goes a bit, but also it's related to what you were suggesting last time, Kyle.
Right.
Is that,
yes.
You know, your launch file basically, and let's forget about, you know, if actually the syntax would allow us to do that easily or not. But if you say launch node A and launch node B, well, you could also say at that time, oh, and by the way, I want topic X of node A to go into the to publish into the and be allowed to talk with the subscriber of node B, and that would give you a way to generate those policies, those DDS policies at runtime, basically, while you evaluate your ROS launch, which kind of limits the amount of duplication of information, and also additionally, it's always so the thing which is tricky there is that there is no tutorial in this design, and it's always hard for me to see. Well, if let's say that I have a motion planner and I want to bundle a default policy with my node, and goal is really there that I make a standard package. Like, I don't know what robot it's gonna run on. I'm not sure how I would do that if it's placed at the package level, versus if you do that at the launch level, you kind of enforce that it's really done where you design your application. Your final application, where you actually know that, well, for this particular node, because of this particular robotic application, I just want those 3 nodes to be able to subscribe to this topic, for instance.
That is ignoring the security type, the origin encryption or signing or whatever. That is the direction that I'm thinking that this would go with the node IDL stuff, right? Where because security only applies after everything's remapped, right? Having it at the generic level is only useful if you can map it into what's actually happening in the launch file. And so that can either happen as the launch file with an input and it's just generated statically and then you maintain it, or it can happen at runtime when the launch file is fired up, right?
Yeah, exactly.
I love that idea. Yeah, that's one of the reasons I was asking if policy files were actually necessary as an intermediate format, because we could just generate the whole thing at launch time.
And for the security type, so again, goes back to, it's easy to add an annotation in your ROS launch in ROS 2 to just say, oh yeah, and by the way, allow that, but I don't know, only if it's encrypted or only if it's signed, or, whatever you want, basically.
Just to clarify, I think you'd still want to do the analysis of the ROS launch at design time, because at runtime, if you wanted to auto-generate the permissions, you also have to sign it, and that would, involve having
with the CA. Yeah, that's true. Which requires it to be on board.
Or you could send off the permissions remotely to the server to sign it, but it still means that you'd have to dynamically have this signing service.
Yeah, although if that was something that people were interested in, right, I want to point out that the launch file also contains all of the nodes that would be involved, which means it could also take care of generating the CA and generating all of the keys on the fly.
Yeah.
We could do a ROS2 launch -- secure.
Well, and also the other thing is that, if it's integrated directly at that level, so my meta concern about SROS is that it's not on by default and it requires extra work. And I would not do a ROS launch -- secure. It would just be a ROS launch. Maybe encryption and security is off by default for performance reason, but you don't need to pull something else.
We could shoot to maybe have sign on by default or something like
that. I think it's robot specific, right?
Yeah. But I think you could still use this policy schema as the intermittent representation before the DDS. Like whatever ROS launch would generate would be we could generate the policy format, and then that gets templated based on what transport you're using. It can remain agnostic to whatever specific transport you're using.
Yeah, that's an option for sure. I mean, yeah. I don't know. Go ahead.
Yeah. And then the last thing I'd like to do is be able to color profiles. So I think it gets close to what you're saying, and you might have certain subsets in your sections in your computation graph that you don't want to talk to each other. So being able to color them and then have the design tool validate that there is no possible way that that there's a topic that these two colored partitions have in common.
Mm-hmm.
And you could have particular bridges that are like of both colors that are allowed to be the intermittent layer, like between the real-time system and the user-facing system, something like that.
Is it like basically translated into like a DDS? I think it's called partitions, right? Is it how it's called? To have like subgraph which cannot really talk to each other?
So yeah, I mean, you could use partitions to segment, but I don't think the RMW layer is currently. I mean, you use partitions for namespacing, but we walked that back after we had a whole bunch of namespacing issues. But
Okay.
you could use partitions with security layers, but I think when you create the topic, you would have to modify the QoS to use that partition. I don't think ROS is going to do it for you.
I see what you mean. Okay.
But getting to, this is on slightly tangent, for like multi-robot aspects, I think ROS 2 is still going, right now it's still suffering from like topic clobbering, where like if you have multiple ROS 2 robots on the same DDS domain, on the same network, they're just going to interfere with each other. Like their TFs are going to mangle, or their eStop topics are going to mangle. So having sort of like a method of managing swarms of robots where maybe every robot's its own partition, and then you can tell ROS like at what scope you want to publish a topic. Is this topic that's like my post broadcast to my partition, or both my partition and the empty partition space, thus like publishing my post to all the swarm?
Yeah.
So I think it's kind of neat to have a concept of not only like a topic, but like a robot in the seam of ROS 2. Like robot having being a first class definition in the IP. That's my rant.
Yeah, I'm wondering if it's a robot definition or a notion of a bridge, or whatever you call it, because I think that like what you want to see from the graph, from inside the robot and from outside the robot is very different. And I wonder maybe a robot abstraction is the right thing to do, but I'm wondering if we just want something which is akin to a firewall, or whatever you want to call it, where basically you just have a local DDS communication, and then all of that, and then you just happens to not serve those like topics outside, and you just have a node doing the translation, becoming your public endpoint, and just providing a subset of those topics, actions, and so on to the outside world, while being very careful for this outside API about how you map it and so on, because then like uniqueness of naming becomes a much bigger issue once you're in this situation. So I don't know, but it's definitely something that we will find very useful on our end.
So what you just described already exists in the realm of DDS. It's called DDS Routing. RTI has their own product for performing DDS routing. So the idea is that you could have a separate process that has it configured, and like what kind of bridge, and like how you want to remap your sort of local computation or your local data bus into the data bus above you, so that you can maybe interoperate. So like the idea is like maybe for a hospital, you might have a data domain for like every floor. So like all the IoT devices on a certain floor of the hospital are like cooperating, and then you might have routing service to the entire hospital where the floors can intercommunicate.
I see. Yeah.
I was thinking of something maybe a little simpler where, you know, the node, the participant is aware on whether something is should be external and internal. That way you could cut down on the overhead, because then you'd have to, you know, do all the serializing and deserializing if you're going to try and
yeah. I mean, for that, I think a lot of that, unfortunately, is due to the fact that we don't have very good IPC support yet in ROS2. I feel a lot of those problems would just go away if, you know, like by default, automatically we had IPC, like our shared memory-based transport for local communication. And in this case, you know, like probably there could be a flag somewhere to just say, hey, yeah, if I'm doing shared memory anyways, and just don't encrypt anything, because like the security is handled by your kernel, and if your kernel is compromised, then there is nothing you can do to salvage the situation anyway. So encryption is not really buying you anything in this case. So I'm wondering if what you're describing in terms of internal external is just, you know, once we're in this world, everything internal would be shared memory. So anyways, that would not be encrypted, and everything external is hopefully encrypted, because you're gonna route that on the open anyway. Yeah. So, and just to go back to your hospital example, which was really great, do you know something which always bothers me with the DDS domain ID? Do you know how like RTI is recommending people to do the domain ID allocation? Do you still need like, you know, to avoid like conflicts of domain ID, if you just do something a bit stupid and let's say you randomize the DDS domain when your ROS2 node, your ROS2 robot starts. Do you know if there is any best practices from a DDS standpoint on that?
I don't know what the recommended allocation. Yeah, currently it sort of reminds me of like the hobbyist RC community, where like everyone had like shitty FM transmitters, and then you'd have to put your crystal on a board, and like if you wanted to use this domain or crystal, you just take it off the board. That was the way of like, that's what OSRF has a spreadsheet where they just like add certain people your name to a certain domain. That's sort of like how they avoid CI content. It'd be nice if that could be like, if there was a smarter way. I think the OMG is going to address that. Is they're going to be adding domain. Like say, I talked to Gerardo last year or last ROSCon, and I think there's going to be a thing called domain tags, and that you'll be able to. So I think that all the discovery traffic will still collide because they're going to be on the same domain, but at least they won't like try and connect in the sense they'll have different domain tags, and then the domain tag is just a string, so it's an arbitrarily.
Well, sounds like they need to reinvent non-routable address.
Okay. It's just another like plane of separation that you can achieve in DDS. It seems useful, but at the same time, it's going to add some complexity.
Okay, well, that's good info. Cool. Yeah. Any other question?
So yeah, that's the policy design document. Please comment if you have any suggestions. I think a lot of this relates to the node IDL stuff, but I still think it's going to help if we have an intermittent representation, and that intermittent representation is succinctly expressive for anything that we want to auto-generate, then that's be fine because it's already very easily machine parsable.
Sure, sounds good. Cool. Any question in the room?
I don't have any questions.
Okay. Cool. Well, thank you, Rafin, for your presentation. Do you think, Zach, time check, we have 15 minutes left. How long were you planning to talk about?
I don't have any documents that I can share, but so I guess I could give a high-level quick talk about it.
Sure.
Okay, so what I've been working on is node sandboxing. So ROS2 launch has the ability to add extensions. So what I'm considering doing is adding a new container for a ROS2 launch, so you can define nodes inside that container and attach a security policy to it for sandboxing. Initially, I'm looking into being able to launch all the nodes in one group inside like a Docker container, and another option is to launch. What?
That is cool. Keep going.
Okay, I wasn't sure if that was a good or a bad And another idea was to also be able to launch a group of nodes as a specific user, since that's kind of like a Linuxy way to restrict file access and directory access. Going back to the Docker idea, one of the things that Docker offers out of the box is restricting of CPU and memory. So by launching your nodes inside a Docker, it would a Docker container, it would allow you to prevent a group of nodes from exceeding its CPU. The percentage of CPU that you allocate to it, and by specifying the memory constraint, you can limit the maximum amount of memory available to that group of nodes. I think that's all I have for the high-level talk about this.
This kind of orchestration was something that we were thinking of doing for ROS1 a few years ago. We're thinking like, oh, could we extend the machine tag to like support containers instead? And the idea was really appealing because then you could sort of use software-defined networking to like bound certain interfaces to the other. So like this is like, before SROS, so that like if you still want to segment partition your computation graph but still have it like interoperate where you're not breaking anything, you could color the nodes on like if you wanted to use something like Kubernetes or Docker Swarm, where it would make sure to provision nodes that are going to like have high bandwidth with each other on the same machine. But this is really neat, like extending ROS launch and ROS2 to use containers. That's really cool.
And something which is also interesting, we started thinking about after, brainstorming for this idea, is that something which is a bit annoying right now with, all those robots, like you take the Turtlebot 3, for instance, all of those like high-level packages containing launch files basically pull dependencies to everything because you need to make sure the nodes exist, and that it pulls the right dependency. So if you imagine, and I think it's still a bit of an open debate, is that you're gonna get, so basically what we would like to pull is a Docker image, which would ideally be the nightly or the latest release of ROS2 by OSRF, like on Docker Hub. So, but it may or may not contain your nodes. But if it contains the nodes you want to run, and you get those from your Docker image instead of, let's say, mounting a workspace on your local machine, well, then what you get is that you break all of those dependencies. You don't need to have like this meta package like with like 10,000 dependencies. You just have a single like independent package, which is just pulling a dependency on like ROS launch itself, and then you just like have implicit dependencies by just pinning Docker images into your launch file and knowing that stuff is gonna get downloaded as needed when you want it. So it opens an interesting things, because you could imagine actually running ROS2 applications without ROS2. Like you put launch on pip, you install launch only, and you run it, and it works.
So you just give someone a method to install ROS launch and the ROS launch file, and then it's going to figure out which Docker images do I need to orchestrate to have I have containers running all these nodes that you specify in the launch file.
Yeah, here you go. And so basically there is no C++ going on anymore. You just need basically to have this Python code released on your on PIP or whatever you want. And it goes a bunch of nice features when you think of Windows and OS X support, because actually, there is a higher likelihood your stuff is gonna, that we can make sure that ROS launch works well on Windows in this situation. You just don't care about the C++ layer, because that stuff is gonna be containerized in a Linux container anyway.
I wonder how you might handle stuff where like the ROS launch is interpretive, and that it needs, like you said, it might have to have the package installed to do the inference to figure out how to configure it. So like one thing is like, I'm going to run AMCL. AMCL has several configs. I need to do the emit index to figure out the path to this config that's defined in the launch file. And so that's a query to emit index, and then I put that in my parameter and then launch. I think it's kind of hard if you're using Python py launch files, but maybe it's something if it was XML, that maybe the parent ROS launch would just spawn ROS launch inside the container, and then that would do the interpretation. So it's more that we just need to logistically know what containers to run ROS launch to bootstrap ourselves.
So that's for sure. It's a bit of a rehash, of the Bloom problem, where everything works well, and then you need to have a Debian release, and you realize that you need to be much more well-behaved when it comes to configuration and so on, because like the constraints are a bit different. So I agree with you. I think the quick hack for what we like Zach would be proposing would be we're gonna pass inside your Docker container whatever Docker flags you want. And so if you need an element index, then you need to mount the right files at the right place, which is not great from a usability point of view, but at least it gets the ball rolling. But I agree with you, for config files and like those kind of side effects of nodes, that's gonna be a bit complicated.
How are you using, so when you launch containers, are you giving them their own software defined network, or are you just passing the host network driver?
I haven't gotten to that point yet, but for the initial state, it's probably just going to use the Docker defaults.
How will hardware access work?
That is not an initial concern, but
if you can have your own Docker flags, you can set the -- device or -- privilege or whatever.
Yeah, okay.
So,
So
you should probably solve that up front. I mean, this is robotics.
I mean, but that's exactly why it's a customizable security policy. Docker is one implementation. I mean, arguably you can separate your nodes in your app into two categories, like things which are taking hardware information and putting that on the universal bus, which is ROS2, and things which are actually computational nodes, which are like ROS2 in, ROS2 out, and with the annoying exception of CPU intensive or GPU intensive computation, which would require you CUDA. And no, we are not going to try to solve CUDA with Docker, at least right now. So you're in a mode where containerization is not a big problem. Like things like TF, there is no reason that TF would not live into a Docker container. After, if you're talking about a LiDAR driver, then the question is, should it be containerized? Maybe, I don't know. I think it's an open question, and it's definitely not something we're going to force onto everyone. And so it's a first pass of, here is the first kind of thing you can use to sandbox nodes, and it's Docker. But another thing we were thinking about would be something as simple as run as, which would be another security policy, which is, well, actually for this subgraph, we're going to run that as another user. And that's going to allow you to just at least make sure that you don't run your frame grabber as root, something as simple as that.
Fair enough.
Yeah. Yeah, exciting. Any other feedback? We're gonna come up with more info on that as we work our way through. Most likely, we're just gonna write something which is more like a POC. So Zach is already working on that, and it's kind of a build and iterate approach. The good thing with ROS launch is that it's plugin based now, and it's Python. So it's not as intrusive, to extend the current design as it was before, which is great, by the way. That's really amazing. So we're just gonna be a ROS launch plugin, and it's gonna be what it's gonna be, right? I mean, it's a POC, and then we're gonna start play with that. The goal is to use that for the workshop. To secure the whatever application we're gonna run there, and so at ROSCON everyone should have a look at how we can make a ROS2 application secure using this POC, or maybe it will be more than a POC by then.
We're almost at time.
Yeah. Great. If no one else has questions, that's perfect.